Okay, top of the hour. Good afternoon to everybody. Welcome to the ACM2Y webinar on AI and community college programming education. Today, we're tackling one of the most pressing questions facing community colleges and the broader tech education landscape, and that is how do we prepare our students for a software development industry that's rapidly adopting AI? Now, traditionally, entry-level coding roles have been the first step in the profession, but with AI now capable of handling a lot of those routine tasks, the grunt code, as we used to call it, the definition of entry-level is shifting. And this isn't just a technical challenge, but it's a pedagogical one for us as well. And there's also ethical and economic concerns as well. So some of the things we want to talk about today, what skills should we emphasize? How do we ensure equity and access? How do we prepare students not just to compete with AI, but also to collaborate with it? So our goal today, not to find all the answers, but we just want to spark some thoughtful conversation, and we'll explore how curriculum might evolve, what employers are looking for, and how colleagues or colleges can remain agile in the face of this rapid change. And probably most importantly, we'll ask what kind of future are we preparing our students for, and how can we make sure that it's one where they thrive? And full disclosure, that opening script was courtesy of Copilot. Okay. And, it's a wonderful tool. And so I tried to make use of it along the way. Anyway, let's introduce our panels for today. And today we have with us Dr. Eduardo Salceda from Dade County, Miami-Dade County West campus of, is it Dade County Community College? I'm not sure. Oh, anyway, he's the principal investigator for the National Applied Artificial Intelligence Consortium, NAAIC, and he's going to tell us a little bit about that organization and what they've been doing in the past few years vis-a-vis AI and college curriculum. We also have with us Iurii Guliev, senior machine learning engineer at Carfax, Canada. He's pinch hitting today for Michael Missamore, who was originally scheduled, but unfortunately got called away by head office, said we need you for this big executive meeting. So Iurii has generously agreed to sit in here. We also have Dr. Magdalene Ravichandran, who's the coordinator of the program here at Fanshawe. We have a postgraduate program in artificial intelligence and machine learning, and she's the current coordinator of that. And again, I have to apologize to her again. I spelled her name incorrectly on the website, and I put an A on the end rather than an E. I've explained how that happened, and I won't go into it again. But anyway, also with us, Professor Jim Cooper from Fanshawe College, who is the founding coordinator for our Fanshawe Post Graduate program in artificial intelligence machine learning. And he's currently course master of the Emergency Technologies course at the Fanshawe Computer Programming and Analysis program. Okay, and I'm Bill Pulling. I'm your moderator. I'm also at Fanshawe College. My co-moderator here, Bill Kearney from Clovis Community College, Fresno, California. He's also the chair of the ACM2Y group. If any of you are not members of ACM2Y and would like to join, please simply just Google ACM2Y. It'll take you right to our website, and there's a nice little join button right there on the front. There's no cost. You don't have to be a member of ACM. We're just a large group of community college educators, mostly North American, but we've got some representation from around the world as well, who get together and we chat about various things and run webinars like this when we can. Okay. Recent media articles, which prompted the rise of the decision to run this particular type of webinar. And again, these are really recent, as I Googled these this morning, and just to give you an idea, ACM Tech News feed for a lot of you probably get this. This popped up in Monday, February 23rd. It just goes and it scours the web for relevant articles. And this one was from the New York Times, dated February 20th. AI is not coming for every white-collar job, at least not yet. And that's by Cade Metz, who gives a very thoughtful consideration of concerns about how AI may be displacing thousands and thousands of workers. On a similar theme, the AI job apocalypse is coming, or is it? By Andrew Coyne. Notice both of them have sort of put in, well, is it or isn't it? Anyway, he also gives a very interesting article, a very good read. AI writes the code now. What's left for software engineers? And that was in the San Francisco Standard just last week on February 19th, 2026. And of course, being in San Francisco, being in the Palo Alto area, Silicon Valley, that's going to be interesting to read that one in full. From The Guardian on Friday, last Friday, nascent tech, real fear, how AI anxiety is upending career ambitions. I started reading that one just briefly, and in the first two or three paragraphs, they talked about a young man who had started out in computer science at a university in Britain. And when he went to apply for his first summer internship and didn't hear back from any of the companies to which he applied, he said, maybe this isn't such a good career path after all. He decided to switch majors. He went into nursing. So he left computer science and went into nursing. And then, last one, it's going to be painful for a lot of people. This is in Fortune magazine, again, from just yesterday. And Jacqueline Muniz, the author, quotes Boris Cherny, who's the architect of Claude Code. Claude, he says, I have not edited a single line of code since November, which so he obviously has great faith within his creation here. But he also, somewhere along the way, makes the prediction that software engineers are going to be extinct in 1 or 2 years. So, we've got different versions of, different thoughts from different writers about where we're going with this. Okay, and so today's agenda. Okay, well, I've done my 5 minutes for welcome and introduction, and then what we want to do now, 40 minutes, we'll set aside for various topics. I'm going to ask each of the presenters here to just give a little chat about what their organization does vis-a-vis AI, and here are some of the possible topics that we can discuss. One of the things we often talk about, one of the foundational skills that will remain essential even as AI takes over routine coding tasks. What do our computing students need to know about AI after graduating, say, with a 2-year degree? Entry-level job. What is the new entry level in software development? And what are the expectations of employers for new hires and required AI skills? And of course, for us, community college educators, how do we stay agile enough to update curricula as AI tools evolve? And then hopefully we'll have some time near the end for Q&A. And this is being recorded, and we will post this up on the ACM2 website when it's all finished. All right, so we start off. Eduardo, could you start us off here? Give us a little description of what the NAAIC is all about, how long you've been with it, and what's the work you've been doing there?
Okay. Do you mind if I share like the website?
Sure. Yeah, you
Yeah.
go right ahead. Let me just, okay, how do I do this? Share. Post tools for share. Okay. Who
Send the
can share?
request.
Okay, allow. Yes, go
There we
ahead.
go. Yes. So I'm just sharing the website so that you can see what it is that you can where you can find it. So we haven't figured yet what to call it. You say NAAIC, we call it NAIC, Nike. We try to figure it, but we are a consortium born from three community colleges: Houston City College, Miami-Dade College, and Mesa Community Colleges, which were the very pioneers in the U.S. for 2-year education degrees in AI. One is robotics, one is engineering, and one is general. So we decided to get together after, much collaboration for our own programs into creating something for the greater good. I mean, that's how we see it. And so we try to help other institutions, 2-year colleges, create programs in AI where they're going to help create the workforce that is needed without much in terms of we're not trying to step on anybody's toes, right? So it's a 2-year, they will be doing drastically different jobs than what a PhD or a master's student in AI would be doing. And so if you want to know more, at the end of the first page, at the very bottom, there's a subscribe button there that you can do. And I wanted to focus on the things we do and how we do those. So we offer curriculum, we offer mentorship, and we offer partnerships with industry. Most notably, we start with three, right? With Intel, Microsoft, and Google. And that's just expanded dramatically since we started in October of 23. So we've had October to 20, October? Yes, this is our second year. October 24. Oh my God, I don't know what year I'm at. Yes, 24 October to 25, 25 to 26. So October 24, we were awarded a grant by NSF ATE of $2.8 million to create this and put it together. And so we've had now two conferences, one conference that's going to happen in Phoenix, Arizona in October. And our partners have been really, really great and gracious in being there for us, in providing whatever resources they have. It could be curriculum like Intel and Microsoft and Google, or certifications or vouchers, all these things to help college faculty get AI ready, and thus then getting their students AI ready. So it's all free. It's all just a matter of joining and then asking. And then there's always resources like, I don't know, every month we have different trainings, for example, to get up to speed. So it's interesting to see the connection that industry has with us, because you would think they're more interested in higher level degrees, but they have such a need for workforce now that they've adjusted the jobs. They're creating these jobs where a 2-year college, degree is enough to get a student started. In terms of mentorship, we select the first year we selected 3, and then the next year we selected another 15 in order to mentor people in different institutions to get their program either started or completed, right? In getting it ready across from either creating frameworks or getting their courses ready, depending on the context they are. And the last thing I'll say about it is we have what you would maybe call it an advisory team, but it's not really just advising. We call it the business industry leadership team. So built that allows us to converse, right? Have this conversation. And actually, at least twice a year, we get together in order to see what's important in the industry. And so we have many, many people that donate their time from different industries, but all related to AI analytics, that kind of work, that tell us what is important to have in the curriculum for our programs, which we then take to our institutions, faculty get together, work through, tell them this is what we're doing, and then it's a constant conversation of what we're offering. Let me go to the resources because there's something you're gonna like. If you're thinking about creating an AI program for your institution, there's something called the KSAs, right? The knowledge, skills, and abilities. And this here tells you what we're actually revamping it. This is a year old now. This was September of last year. We're revamping it because it's going to tell you what all these wonderful people think is important for a degree. Now, this is generally speaking not contextualized, right? You have to create your own group of people and team that will help you do this. But this is a great starting point for us, where we say these are the important knowledge categories that you need to know in no particular order, and also the skills. We don't go into abilities because that's more like later. And you only need to have a .edu address in order to access this. It's completely free. We just give you access to these. So our mission is basically that, just share what others have done who have paved the path in community colleges to then really create the workforce across the US and I guess North America in general.
Okay, thanks, Eduardo. That was a wonderful summary. Yeah, when I first came to your site, I thought, oh my gosh, this is an absolute gold mine here. Well, maybe even better, it's a diamond mine. But and then I saw the requirement says you had to have an EDU address. And okay, in Canada, we don't have an EDU address. So I was wondering, somewhere along the way, we'll have to, have a discussion and see if we can expand that so that we can get, you know, fanshawec.ca. Would love to grab a hold some of your material there. Okay. Um, let's see. Would you be able to throw the link in the chat? Yeah, I think. Okay, thanks. Bill Kearney did that already. Wonderful. Okay. Okay. Iurii, if we can call on you here. All right. Iurii Guliev is with Carfax Canada. And as I mentioned to folks just at the start, Iurii's pinch hitting for us today. The original guest, Michael Messmore, was unable to attend because he was called away by management for some reason. Needed to have some sort of meeting, I guess. But anyway, Iurii has graciously agreed to step in here and pinch hit. And from the industry standpoint, okay, how are you using AI. What are you using it for? What tools are you using? And how has it affected your productivity? And what do you need from your new hires? What are you expecting or hoping for from your new hires when they come in?
Uh, Thanks, Bill. That's a lot of questions,
Yeah,
and I
I'll
think
repeat them if I.
I'll start with the introduction first.
Okay.
Uh, so again, my name is Iurii Guliev. I'm a senior machine learning engineer at Carfax. I worked at Carfax for more than 5 years, and I joined in uh, around like late 2020 when I saw some interesting developments in the field of AI. Originally, I'm coming from the field of applied mathematics. I have a bachelor's degree, and uh, in 2020, I stumbled upon an interesting game where the plot of the game was randomly generated, and I was trying to figure out how it works, and I couldn't wrap my head around how can I provide so many different outputs that at the same time don't make too much sense. What I found out later is that it was one of the first early generative LLMs called GPT-2. It was like the API of OpenAI was applied in that game, and that's how I got into the field. I got very interested and was looking for any opportunity to join the field. And Carfax was just starting the AI department at the time. So they had opening roles. They were still called software developers. So I applied as a software developer, but in the machine learning field. And then I became one of the first machine learning engineers in the company. So throughout the 5 years, I was working on many projects, and I can share my screen for some of the work that Carfax does at a high level, and then get more into the details of application of AI. So first of all, Carfax is a well-known company in the United States, also growing in Canada, expanding very quickly. We focus on vehicle history reports, and we have also a website for selling vehicles. Uh, our inventory is quite big, but our main selling point is the history reports. For any vehicle, we provide a lot of history information. What's the good value for the car? How many accidents did it have? How was the maintenance? And how many owners the vehicle had? So it's really rich history for every single vehicle. And we focus on 3 time frames. We focus on the past data, like odometer readings, maintenance. We focus on the present data, in what condition the car is right now, where it is, what's the best value for it, and on the future data. We're also trying to predict reliability. And AI applies in a lot of components of our modern infrastructure. For example, as for the projects where I was involved specifically, one of the biggest projects we had is the natural language processing uh, for maintenance records. For example, many dealers, they send information in very different formats, in very different phrasing. Like some mechanics, they like to put comments manually, which makes the analysis very difficult. It's very difficult to write a program that would accurately handle all the different variety of text. So that's where we first applied, let's call it small language models, models like BERT or earlier transformers. And those models would analyze the text and just simply return categorical outputs of what service was performed at the time. And we would propagate it to the database and enrich our system with a lot of data that was missing previously. Because again, any string matching, any previous technology, it wasn't able to capture as much data as accurately as artificial intelligence. And that was my first application of AI. That project right now is in a very mature shape and still runs well. Like no other technology was able to beat it. LLMs Modern LLMs are a big competitor, but they're still a bit too expensive to run on billions of records. So there's always a balance between accuracy and cost. And since that time, since that project was delivered, our AI department was expanding very quickly. From around 20 people, it expanded to more than 100 engineers, and the application of AI as of today is very wide. For example, even on our main history report page, I'm not sure if you can hear the audio, but yeah, I think the audio is not shared, but here the Fox is speaking in the Carfax voice and speaking specifically about this vehicle, what maintenance it had, what accidents it had, what value is at the moment, and the voice is fully AI generated. We have a team that does text to speech. We're also experimenting with video generation because obviously an actor cannot voice records for millions of vehicles every day, since they update every day. But here on the fly, we generate live audio data for every single customer who sees those pages. So that's another cool application. And our application is not limited on that. So we have a lot of agentic systems. This is experimental work. We had a lot of OCR, where we process PDF reports from police agencies. We have a lot of pipelines that just analyze data. And with today's AI, I think the possibility is unlimited. Like what kind of data we can extract, how we can apply it. We're still exploring the potential use, and the work is just not stopping in this domain. So this was about the application of AI as a functionality. But I think for today's meeting, we're talking more about productivity and how does it relate to the software engineers, how their day-to-day looks like, and how AI coding tools change that. So that's a separate topic, and we can go into a lot of details. So I'm not sure if we want to pass it to the next speaker and address that
Okay.
later.
Yeah. Okay. Yeah. Hang on to that thought, Iurii, and we'll maybe pop back in there. Magdalene, if you could just maybe give us a little chat about the program here at Fanshawe, the postgraduate program in machine learning, and how do you see AI, altering your curriculum? Like, has it changed significantly since you first started the program as newer and stronger models come out?
Sure, thank you, Bill. I'm just gonna probably post the link
Okay.
on the chat and then talk a bit about it rather than sharing the screen here. Okay, so let me introduce myself before I talk about the program. I'm Magdalene. I'm the professor and program coordinator of the postgraduate diploma program in artificial intelligence and machine learning here at Fanshawe College in London, Ontario. Yes, and so what do we teach in the program before we move on to that? I know AI isn't the hot topic anymore. I think it's gone. It's pervasive now. It's affecting almost every corner of technology, be it software, data analytics, automation, call anything. Now it's started showing up everywhere. So here at Fanshawe, we have this postgrad diploma program that we teach the AI foundations, where students learn machine learning and AI algorithms from basics. That's what we start with. And they also continue developing their practical and coding skills and go on to develop AI applications towards the end. So this means they also work with the real data sets, and they create these applications, and then and try to make sure that they are ready for the industry. And as part of that, we have different courses that we teach. We start with basics of machine learning models, introduction to data science, and we start with introduction to Python programming and so on. And then we dive deeper into courses like TensorFlow, Keras, PyTorch, and all these libraries that are well known in machine learning applications. We teach them everything in detail, along with NLP applications, like Iurii was mentioning. He was working with NLP applications. So we do have students, we prepare students for those type of applications as well, and machine learning, security, data mining, and so on. So quickly talking about what our program actually does is, I know people, when we talk about AI tools, everybody, we talk about how teaching them to use AI tools. I mean, when ChatGPT came into picture, we were like, oh wow, it sounds great, it sounds amazing. And but there were also people who are struggling to use these AI tools, right? To understanding how it works and trying to get their hands on different AI tools. But now you can see that almost a lot of applications, including the basic productivity apps that we use day-to-day life, also have some AI element added to it. There is AI integration into it, and we don't know how it works now. And every application that you touch right now has some kind of AI tool that's embedded into it. So here in the program, we specifically teach the students. Of course, they use these generative AI tools, like they try to use these LLMs, but we also teach them to develop these AI applications, and model APIs is now, part of the development workflow. They try to include these AI tools and also try and understand when to use the AI tool. And that's something quite interesting, because I know businesses now start integrating AI tools, use some kind of AI tools to explore how their business can progress. But the other question is, like, it comes down to the basic question: do you really need AI to solve that problem at hand, or is it easily solvable without an AI tool? So we teach students also to understand when to use the AI tool and why to use it, in addition to, uh, in addition to teaching them with how to develop an AI application. And in and after we do all that, there's also an important part of the equation that I think most of us miss in regards to AI is, what are the ethical implications involved using AI, such as bias in the training data? And I know this is one example that I keep talking about, and maybe we can overcome the bias right now with much more penalty-based system, that where we penalize the models for coming up with the biased prediction. But there was this, I think Amazon came up with this recruitment tool, which kind of biased on the historical data, where we're trying to work against the bias, where we're trying to move forward when women are trying to achieve in STEM, move forward. And the Amazon recruitment tool was just feeding on the bias that was already there, and the output was also biased. So those kind of discussions around this ethical AI is, I think, is very important with the student community to understand that there is bias in the training data. How do we overcome the privacy concerns? How do we establish fairness in the model's output? How do we bring about the accountability and transparency with the outputs that we receive from the models, right? And so we do have case studies that are part of the program, that we talk about where the ethical failures when using AI models, and we have discussions around biased models and how do we overcome that, and so on. So as a part of that, towards the end of the term, the students work on capstone project, which is a project-based learning, where they build their portfolio. They come up with an application from scratch. They have their interest, whichever interest they they want to build an AI application for. They come up with it, and they create an entire AI based application as part of their capstone project, which which is great because they have these project-based experience, and it also adds to their project, to their portfolio, which helps them when they get out and get ready for the market out there. So just a conclusion about from education perspective. I know I've been talking about AI from a different perspective, where we teach about where we teach the students not just to use the AI tools, but to develop these AI applications altogether. But as educators, the responsibility for us when we develop these graduates who are in computing fields is to not just teach them what AI is or to just make them understand what AI is, but also to make them understand how to use it responsibly, and also to decide between where to use it and where not to use it, and also to understand how they can use these AI tools to the benefit of the human community. And yes, so I think it's again our responsibility to prepare students for not just for getting into jobs, but also understand and adapt to this AI-driven world. With this, I will conclude, and also I'm looking forward to great, insightful discussions that we will be having after that.
Okay, Magdalene, thanks very much. I'm glad you touched on that ethics and responsibility aspect. I did have a few questions on that. We'll probably come back to that a little later. Okay, I'd like to ask Jim Cooper to step in. And Jim and I are two of the old hands here at Fanshawe. In fact, Jim has been here a little longer than I have. In fact, the thing I like to tell my students is that Jim and I both started programming using punch cards. So that tells you how long we've been in the game. Yeah. Anyway, Jim, you teach the Emerging Technologies course in our 3-year CPA program, and I imagine it's one of those courses where you can't use the same curriculum from semester to semester anymore because it all has to be.
Yeah. Yeah, that's true.
Yeah.
Let me just share the screen.
Okay.
Bill, and I have, as a typical educator, I have slides, right? I've always got slides.
Yep.
Okay. Let me just run my slides.
Okay.
Okay, there we go. I must apologize up front for the red, but that's the Fanshawe College color scheme, right? Red and white. So unfortunately, that's what we're stuck with. I always say to my students, if you start to get a serious headache, it's just because of Fanshawe College and the color scheme. So anyway, what I want to do is really focus in on a single course. And this is a course that's part of our CPA program, the Computer Programming and Analysis. And it's one of our flagship programs. And the problem that we had is that we didn't really have any machine learning or artificial intelligence in the program. And so we wanted to get started with something. And we had this Emerging Technologies program, which was in need of an update. And so I guess it fell on me to do the update. So what I'm going to do here is just give you a quick overview of the kinds of things that we did and what worked and probably what didn't work as well. So first of all, this is in terms of the course framework. This was a course that was in the final semester. So our CPA program is 6 semesters. And it has, in addition to that, 3 co-op terms. So by the time the students get to level 6, on the one hand, they're probably looking forward to being finished, but on the other hand, they're also pretty good. They've had a lot of really good training, and they've also had some co-op experience, so they know what's going on in the marketplace and so on. And the last time this program ran and where I was involved with it was the fall of 2025. And, it was a typical 4-month long course. So, we had to do it all in 4 months. And the basic structure was 2 hours weekly in class. So we had lectures, demonstrations, discussions, that kind of thing in a face-to-face environment. And then in addition to that, we had a 1-hour weekly asynchronous online session. So I did a recording for the students, and I would post it on our website, and then the students would, theoretically, they would download it and listen to the video recording. As far as what the course was about, this is the new version, not the old version, but because we only had one course and we wanted to do something worthwhile, we focused most of the time, not all of it, but most of the time on having the students build a GPT type large language model from scratch. And we fortunately had a good textbook for that, which kind of helped. But we also wanted to do a couple of other things. So we inserted where we could some of the concept of AI assisted coding. And I should say, if we were going to do this again, we probably would want to get into some of the more, current stuff, which involves agents, right? And working with the use of agents in constructing software systems. But for this first run of the course, we didn't really do that. We just kind of did things informally. We focused on prompt engineering and that kind of thing. And then finally, we also wanted to talk a little bit about the concept of AGI. And this was done because I think students are interested in this sort of thing. I guess in particular, how far along the path are we as far as large language models go? Are we, well along the path towards artificial general intelligence, or are we just kind of getting started? So those are the sorts of topics that we discussed from time to time. But I should say the main focus was in doing the large language model. I won't focus on that. I'm not sure I even should have put this slide in, but just to give you kind of a breakdown of the course evaluation, we had a couple of midterm, or a couple of tests, I should say, a midterm test and a final test. And then we had a couple of projects, which were significant pieces of work for the students, at least they were supposed to be, and worth a significant part of their grade. And then finally, we had 5 labs that we had them do that were only worth 4%, but obviously, it adds up for students who maybe don't do the labs because they don't think they're worth that much. As far as our course resources, we had a very good textbook from a guy named Sebastian Roshka, and it was the exact topic that we wanted to focus on, which was how to build a large language model from scratch. And this is a Manning book, so it was available in PDF or paperback. And in addition to that, the author had some very good video recordings on YouTube about it. So it was the kind of thing that for a guy like me, I really liked this because I could put in some other things into the course that maybe had nothing to do with the large language model directly, but then I knew there was a lot of support stuff that students could access in his textbook. As far as software was concerned, this was mostly a Python type of course, not entirely, but students had to install, if they hadn't already done so, Python. And of course, it was a PyTorch thing. So if we were, like a lot of what people are doing with training large language models, it's all around using PyTorch. Not 100%, but it's pretty commonplace. But now here's the main problem that we had to deal with, and we had very good students in this course because they had all been through multiple programming language courses. So they'd done C and C++ and Java and C# and so on. So they were typically very good programmers. Plus they had some co-op work experience, but they didn't really know much about artificial intelligence or machine learning in terms of the technical side. So we kind of had 2 or 3 weeks that we had to crunch through, sort of a basic startup on all of those kinds of things. And we were also dealing with students that we could not count on their math background. So they typically did not have, calculus experience or, really any other, even statistics and that kind of thing. So anyway, we crunched through. We started with this example, this MNIST database. Some of you may have heard about it, but it's considered the hello world of deep neural networks. And it's the idea of having a database of images of hand-drawn digits that the system can learn from in order to be able to recognize hand-drawn digits, in the future. So it's kind of a classic case of, basically supervised learning. And another area where as part of this sort of heavy-duty startup, we wanted the students to get some exposure to was the concept of word vector analogies, because getting them into learning about large language models kind of required them understanding this concept of word embeddings, where we're interested in the proximity of words to other words and the relationship that exists there, and the transformer algorithms that they need to know and they need to work with for large language models kind of depends on this basic understanding. So we actually had the students do a project that to create a Python application, which was going to be a version of word vector analogies. And I kind of helped them out with this because I gave them an initial version that was coded up in C#. So it at least gave them a starting point. And it was based on, they had to use the data that Facebook had put together for this particular purpose. So, we gave them all the links and so on to get them started. And this is what the data looked like that they were starting out with. It had, a lot of words, in this case, 1 million words. And for each word, there was a 300 element vector, floating point values, which defined the relationship of that word to other words in the context. And one of the requirements that we had for this project was that the students would copy my user interface, and I guess this was part of the idea as well, because as I think Bill referenced, one of the problems that we have, that we all have, is this idea that students are using the technology to do less work. And what we really want them to do is to learn from using the technology to develop other skills. But they can't really, they're never going to become good programmers or to understand programming if they don't actually do the work themselves. So, that's a challenge. And, I'm not sure with this course that we really solved much of that, but we tried some different things. So what we did in this particular project, we had them create this particular user interface using Python. And I'm sure a lot of them used large language models to kind of help them do that. But again, this was a simple thing in a way. It's the concept of doing word analogies, which all human beings are pretty good at. Something like, man is to woman as king is to queen, or, man is to woman as prince is to princess, and so on. So that kind of thing. But from our standpoint, what we were looking for was that they would see that this would be really beneficial in how large language models would get trained. So this would be kind of the output that they would end up producing. I actually even had them do the colors because I knew that would be a little bit of a challenge, not much, but a little bit of a challenge with Python. It's not quite as easy as it is in C#. So in this case, the numbers really indicate the probabilities of this being, the best choice, that kind of thing. And so we had them do that, and I'm sure a lot of them cheated. They went ahead and used the large language model to minimize their work. But I was okay with that for this particular first project because we were sort of early in the course with it. And the second thing, and I'll kind of mention this really as kind of a wrap up on my commentary here, but what we wanted to do also was to talk to them about AGI and the difference between what large language models do, that, you know, they're very useful, they're very powerful in some ways, but are they really intelligent? And, you know, that's certainly a valid question. A lot of people have that question, of course. So what we did, we exposed them to this concept of what's called the ARC AGI puzzle set. And in this case, ARC stands for Abstraction Reasoning Corpus. And it was created by a guy named Fanshawe. So you can find it if you want to, you know, look it up on GitHub. It's certainly available to download and you can play with it. But it's certainly based on Chalet's definition of what he was trying to do here. This is considered the IQ test for large language models. And this is one of those areas where, you know, it may open up opportunities for us in terms of how we deal with our students. Because one of the things that we can do, if we can find ways to do it, is to have our students do things that large language models are not very good at. And so one of the focal points here, and one of the, you know, things that Chalet has always said about his ARC puzzles is that large language models are typically not very good at solving these, whereas human beings are in fact quite good at doing it. But here's a typical ARC puzzle, if you have not seen this before. And you can see on the left-hand side, you know, you start out with a number of what are called task demonstrations. So there's really a starting state of a grid, a matrix which has pixels in it, and can be of varying sizes in terms of length and width. And then there's a finishing side to this. So what happens is, what we're really saying is that the first grid becomes the second grid, and the first grid becomes second grid on the second example, and so on. And what you're looking for as a human being is to say, well, you know, what's the pattern here? Like, what is the transformation that's taking place? How do I change the first to the second, and so on? And human beings are really good at this because we have an instinctive, or if not an instinctive, certainly a learned skill for being able to do this. But LLMs are not that good at it. Now, they become better by, you know, the training that they go through. So, you know, there are certainly some versions of this that they can solve. And there are others, the newer versions, as they get published, as Chalet publishes them, they are not as good at. But in this case, once we've looked at our task demonstration and we think we understand the pattern, then we can prove that by, you know, having, in this case, a test case, and we convert the test case and then we submit it. And, you know, it's a totally manual thing, really. But if you're right, and in this case, you can see what the pattern is. I'm sure everybody's looking at this can see it immediately. It's a fill pattern, right? So, you know, in any situation where we have black pixels surrounded by green pixels, then we want to change the black pixels to yellow, and you know, again, this is a fairly simple example, but this kind of highlights how the ARC puzzles all work. They all work the same way. Some of them are just more complicated than others. So just to finish up, our student project essentially was to get the students to solve 3 of the puzzles, and then they had to create a web page that solves each of those puzzles, and they had to do that manually. And what I did is I actually gave them an example really of the art puzzle that we just looked at that was already coded up. And I said, okay, you can't use this one in your submission for this project, but it'll give you the idea that, we expect you to code it up manually, and so it will work. And then what we want you to do is we want you to pick an LLM, whichever one you want. It can be GPT or Claude or whatever, and have it solve the same puzzle. And of course, in a lot of cases, they found that the LLM couldn't do it, or it came back. Of course, LLMs can always do it, but sometimes they give you the wrong answer. So, and I said, don't worry about it. It's not the sort of thing that we want you to go back and iterate through it in order to get it to come up with the right answer, because that might not happen. But just give us the first result that you get and submit that, and we'll go with that. But that was basically what we did. And I guess in finishing up, looking at the results of the course, I think we made some progress. But I think as far as doing the course again, it should be now, because this is where we are in large language models, particularly around coding, which is what the CPA program is all about, or mostly about, is working with agents. And so I'm not sure, at this point, despite all the work that was done in setting this up to do an LLM from scratch, is the fact that we wouldn't do it again. Maybe we should focus on having or teaching the students how to work with agents so that they can write software from a higher level. And I kind of see that as the future, because we can already see, I think, that large language models, if you give them a small enough scope, they can create pieces of software that are quite reliable and quite correct. But they kind of need, at least at this point in the game, they kind of need structure in order to create software systems where there's a lot of code and there's a lot of interaction between the pieces of code and so on. So, as part of the theme for all of our discussions here is really the idea that we're going to have to make sure that we're training our students maybe more as systems engineers rather than as coders. Anyway,
Okay.
Enough said.
Yes, Jim, thanks very much for that. Geez, if I'd known you were going to do that, I would have tried to sit in on your course last fall. But anyway, okay, let's throw open the last 10 minutes here or so for questions. If anybody has questions, please type them into the chat box. And I'm going to start one off. Iurii, can I ask you? All right. If you were in a hiring mode, okay, if you were looking to hire new programmers to join you at Carfax, okay, what kind of AI skills would you hope that they have? With what Jim has just described here, is that helpful? Is that going along the way? Is that getting the kids into the ballpark?
Yeah, I think that's definitely helpful. I think any use of AI today is very helpful, because in our company, as of now, there are three categories of people. One is heavy users of AI who use it every day for every single line of code. Then moderate users who use it a lot, but still not for critical parts. And light users who still use it every day, just for research purposes. But the main point is that everyone uses it, and everyone uses it every day. So it's a very critical skill as of today. And as was pointed out, AI is still keep advancing and keep getting better. Even ArcAGI benchmark, the first version of it was saturated. It's pretty much human performance on this benchmark. ArcAGI 2 is getting close with the recent Gemini model. I think it's close to 90%. And therefore, ArcAGI 3 is coming out. So it's always difficult to keep up at the latest releases. And we're looking for people who understand how to use the latest technologies. And I think it's even good that a lot of students use it to help it with their homework, because they are experiencing the real work environment, because everyone at the workplace right now uses these tools to help design software, to work on the code, and automate a lot of the processes. But it's still important not to forget the critical thinking, the understanding of architectures, and the basics. Because if you generate a code and you don't know what it's doing, I believe there's a lot of danger, and I've seen real life examples of that, where people delete what was not supposed to be deleted, or publish code that's completely irrelevant, that breaks systems. There are safeguards being implemented as of today for all these agentic tools. But still, I believe that it's really important to understand the core of each project and the core of every technology to use it properly. Because AI is a very easy tool to use, but it's also has a lot of consequences.
Okay, and we have one question that came up from Abida. What coding skills, if any, would a student need to be useful in industry currently? Which ties into something I was going to ask as well. What foundational skills remain essential as AI takes over routine coding tasks? Iurii, if anybody else wants to jump in on that one.
Yeah, I can add a few more comments on that. So we need to remember what is the core of software development. It's not just writing code. It's understanding the problem, designing the solution, then implementing the solution, and then verifying that it works. All those are very important skills, all very different. And if AI automated one of those, it doesn't mean that everyone is a software developer now and can do the job of architects and the senior developers. It's still important to have the basics in all of those domains. And maybe the coding itself is just going a bit on the backside, because all of that is being automated very quickly.
Okay. Any others? Nothing popped up. Okay, another question I was going to ask, and it comes back to Magdalene. You made comments about ethical use of AI. What role should community colleges play in teaching ethical AI use and bias awareness and responsible deployment? Where do we fit those into the curriculum?
Yeah, I think I kind of touched a bit on that, not too much in detail, I think, but like as a part of the curriculum, I think we should include the ethical implications of AI as one module somewhere, wherever we can fit it in. I think that would be great. As of now, I can talk for the course. I can talk for the course that I'm teaching and the program that I'm in. We do have case studies to discuss about these ethical implications. We talk about when we do train the model, we talk about, hey, did you check the data? Like, did you look into the data set? Do you think it's biased? How do you remove the bias from the model's output? And also, we talk about the privacy concerns and I think the discussions and adding that particular module in one of the courses, I think would be a great way to start.
Okay. And here's another question. How do we balance teaching traditional programming languages with teaching students how to collaborate with AI tools? Eduardo, haven't heard from you for a little while. You want to jump in on that one, or any thoughts?
I think it's a hard balance, right? Depends on who your consumer, right? Your student is. The tool is going to be there. I'll say that, right? As Ilya is saying, we're all using them. It's the how we're using them that's important. And to Magdalene's point, we created a full course on ethics because we wanted them to make sure that they would know, the correct use. And then every other course has sprinkled it all around because we're we're terrified of them using these for bad stuff, right? So it's important for us to say, don't go against it because it's here already. People are using it, people are expecting it. So how do we change the way? Depends on the course, right? Computer scientists can do it very quickly because this is our domain. But English teachers have to adapt, and it's taken them a little while, right, to do things that they would otherwise do, pre-AI would be how they've been doing, the work.
Yeah, I know. I've been struggling with this one because, I've been teaching introductory programming for 20 years now. And, I've gotten into a way of through trial and error, we found out what seems to work well for the majority of the students, what doesn't work well. And then you're trying to build a foundation of knowledge, a foundation of knowledge that seems to be not getting built really well these days. If students can just go to ChatGPT to find the answer. I guess I was an old hand who said, if you spend half an hour trying to figure out the problem yourself and you succeed, then you're likely going to remember the solution a lot and the process a lot better. The process of solving the problem rather than just saying, oh, I can't get this. 5 minutes later, I'll ask ChatGPT and boom, there's the answer. But okay, did they really understand the process behind it? Okay.
I use the word struggle a lot. I say you have to struggle through.
Yes.
Let it, don't resist the temptation, I say, of using it immediately when you're in a learning environment.
Yeah, yeah. Iurii, prompt engineering. How important is it for kids to, well, if you're asking Claude or anybody to write some applications for you, how much time do you put into, doing the prompt? Or is it a repetitive process? You start out and then you just refine. Is it, do you put a lot of work into the prompt to begin with?
Yeah, so in my opinion, prompt engineering 2 years ago was extremely important. Today, not much.
Really? Okay.
AI understands a lot of the things very quickly. You don't need to provide like for zero-shot predictions, like examples of what you want to see. You don't need to go into too many details, but it's very important to provide all the context. Like you need to understand, like if you're building a system, you're building it in a certain environment with certain constraints. You expect a certain performance. AI doesn't know any of that. You need to put as much relevant information as possible. And that's what usually gives the best results with the modern agentic systems. With older LLMs, of course, prompt engineering was important, but today I would say not anymore.
Okay. Thanks very much. Well, I'm looking at the clock here, folks, and it's just a little after 4, so we're going to have to shut this one down. Thank you to all of our panelists here. This has been an excellent, fascinating conversation. Eduardo, Magdalene, Jim, thanks very much for making the time, and Iurii as well. Thanks for pinch hitting and coming in. Been a lot of interesting stuff today. Do I have to read the prompt engineered closing statement? I guess I should. Okay. As we've heard today, the rise of AI and software development is not just changing the tools we use, it's reshaping the very definition of entry-level work. For community colleges, this is both a challenge and an opportunity. We must ask ourselves, how do we prepare students not only to code, but to think critically and to collaborate with AI and to adapt to careers that may not even exist yet? The conversation does not end here. What we've explored today should spark ongoing dialogue between educators, industry leaders, and students themselves. Together, we can ensure the curricula remains relative, equitable, and future-focused. Our responsibility is clear to empower the next generation of developers to thrive in an AI-driven world. I almost think that the AI is thinking, I got to push in some stuff here that's going to promote my use here. So anyway, thanks to Copilot as well for all of that. Again, thank you to everybody for joining us today. And the recording of this will be posted on the ACM2 website shortly, whenever that happens. I'm not sure how long it takes to get the whole thing processed and up there, but I'll look after getting it up there. So again, Eduardo, Magdalene, Jim, Iurii, thank you very much for everything. And thanks to everybody who came in and joined us today. Bye-bye all.
Thank you. Bye-bye.
Okay.
Bye.
Bye-bye.
Thank you for having us, Bill. Bye.
Yeah, thank you.
Okay.
Thank you all.
Okay.